the following properties. You now see compression here, and then rarefaction. You now see compression here, rarefaction, compression. If we look at the second figure here, you really understand. So you see that the molecules here are closed apart. So this is the area where we have compression. At this point, the molecules are closed apart, and then the rarefaction, you have expansion. If you don't call it rarefaction, you call it expansion, compression, expansion, and all of that. So where you have the compression is similar to where you have the crest in a transverse wave. And then where you have the rarefaction or the expansion is similar to where you have the trough in a transverse wave. Okay. I hope you're following what I'm trying to say. All right. The next thing we are going to look at is polarization. Polarization. So before I continue, I want us to just look at this very figure here, figure 24.25. You now see this is an unpolarized light traveling in all directions. And the B here shows that that light has been polarized. Of course, you know light is a wave. It has been polarized. So it is now made to travel only in one plane. So you see the figure here representing polarization. This one says a schematic diagram. Figure figure 24.24 here represents a schematic diagram of a polarized electromagnetic wave propagating in the x direction. So you see the x-axis here. So it shows an electromagnetic wave which is being polarized, and the wave is traveling in that plane. Okay, let's see what we have here. Polarization of light. Polarization of light. Polarization of light. Polarization of light. Okay, what is polarization? A wave is said to be plane polarized if its vibrations occur only in one plane. The wave is said to be plane polarized if its vibrations occur only in one plane. This plane is called the plane of polarization. How can light be polarized? Let's go down. We will see another figure here. This one shows unpolarized light. So you see the arrow here showing us unpolarized light passing through the polaroid P. The moment it passed through the polaroid, you see that the light began to travel just in the vertical direction, just in one plane. So see the same thing here. Now, it passed through the next polaroid Q. You can see that the light is still in that direction, but this one was being rotated. At this point, the light could not pass through to the other side. It became attenuated because it can only pass through one plane, and that polaroid has been is being rotated. It can only pass through that plane, and that polaroid is being rotated. Okay. Let's go back to other figure. All right, I think we can move ahead. We have some study questions here for us. This one says, which of the following waves can undergo polarization? This is a simple one. Gamma ray, sound waves, water waves, wave on a string. So which of the following waves, from what we have discussed so far, I believe we should be able to answer that question. Okay. This other one says, one of the following waves cannot undergo polarization. Gamma rays, sound waves, radio waves, and microwaves. One of the following waves cannot undergo polarization. Okay, so sound wave is a longitudinal wave and as such would not undergo polarization. Okay, let's go to the third question here. Which of these is not a property of longitudinal wave? Longitudinal wave. Which of these is not a property of longitudinal wave? So when you come here, you see some properties of longitudinal wave. It can be compressed. It has extension, compression, and you also have other properties of wave, like it can reflect, can refract, it can interfere, and all of that, but it cannot plane polarized. Let's read this again. Which of these is not a property of longitudinal wave? Compression, expansion. In the absence of expansion, you can see something like rarefaction. They mean the same thing. Okay, so don't be confused about that. All right. I think I should continue. The next one, diffraction, polarization. Okay. The next question here is, how can a wave be plane polarized? How can a wave be plane polarized? A wave can be plane polarized when we use what they mean by polarizers. How can a wave be plane polarized? Wave can be plane polarized when we make use of polarizers. A wave can be plane polarized by the use of polarizers such as tourmaline crystal or polaroids such as quartz. So wave can be plane polarized when visible light is made to pass through polaroids such as tourmaline crystal and quartz. Okay, let's go to the next item, which we have here, polarization and its application, applications of polarization, uses. We don't call it applications, we call it uses, uses of polaroids. I think that's the best term to use, applications of polaroids. Okay, applications of polaroids. The following are applications of Polarization. Polarization is used in sunglasses. Polarization is used in sunglasses, vehicle windscreen, glass doors, windows to reduce rays of light or beam of light, to reduce glare. That glare means ray or beam of light. Okay. The next one here is that Polaroid filters. Polaroid filters. The next one here is that Polaroid filters are used in plastic industries for performing stress analysis tests. So Polaroid filters are used in plastic industries for performing stress analysis tests. Another point that we have is that three-dimensional movies are being produced with the help of polarization. Another point we have here is that polarization is used for differentiating between transverse and longitudinal waves. So Polaroids help us to now distinguish between the transverse and the longitudinal wave, being that the longitudinal wave may not be able to undergo polarization. Okay, the next point we have is that infrared spectroscopy uses polarization. Polarization is being applied in infrared spectroscopy. In seismology, to study earthquake. Okay, so applications of Polaroids. Polaroids are used in sunglasses, vehicle windscreen, glass doors, and windows to reduce glare, ray of light or beam of light. So they are being applied, they are used in sunglasses, vehicle windscreen, glass doors, glass windows, and all of that to reduce light glare. Polaroid filters are used in plastic industries for performing stress analysis tests. Three-dimensional movies are produced and shown with the help of polarization. Polarization is used for differentiating between transverse and longitudinal waves. So polarization is used to differentiate between transverse and longitudinal wave with the help of the Polaroid. So longitudinal wave would not be plane polarized. So longitudinal waves would not be plane polarized. So longitudinal waves would not be plane polarized. It's only the transverse waves that can be plane polarized. Okay, the next one we have here is infrared spectroscopy uses polarization. So polarization is being applied in infrared spectroscopy. Polarization is applied in seismology to study earthquake. Okay, let's go through quickly. Let's check the questions, the study questions we have here. This one says, which type of wave cannot be polarized? Which type of waves cannot be polarized? Answer. Longitudinal waves such as sound wave cannot be polarized because the motion of the particle is in one direction. Because the motion of the particles is in one direction. So that's the reason why they cannot be polarized, because the motion of the particle is in one direction. This other one says, what is meant by the plane of polarization? What do you understand by the term plane of polarization? A plane in which electromagnetic waves vibrate when it is polarized so as to vibrate in a single line. So that line that you saw here is what they mean by plane of polarization. Okay, let's go back to our question once again. What is meant by the plane of polarization? A plane in which electromagnetic waves vibrate when it is polarized. So a plane in which electromagnetic waves vibrate when it is polarized is known as the plane of polarization. This question here says, what is a polarizer? What is a polarizer? A polarizer is an optical device that can convert an unpolarized light, wave into a polarized light wave by blocking all other vibrations. So a polarizer is a device that converts an unpolarized light to a polarized light. Okay. This other question is, what is an analyzer? What is an analyzer? The answer, an analyzer is an optical device used to determine whether light is plane polarized or not. It is an optical device used to determine whether light is plane polarized or not. Who discovered polarization of light? The French physicist whose name was Etienne Louis Malus, who discovered the polarization of light. The person who discovered the polarization of light was a French physicist by name Etienne Malus. You can see it here. Okay. So here you have some study question as well. You just test your understanding. I refused to put some options here. Didn't see it to be that necessary. But let us look at the questions. At least we will learn something from this. This one says, what is a wave? A wave is a force that propagates from the place where it was created. This one says, a wave is a disturbance that propagates from the place where it was created. This one says, a wave is a matter that provides volume to an object. This one says, a wave is matter that provides mass to an object. So which option would you choose if you were in an hot seat? Maybe you were writing an exam